where you needed to create this scatter plot on your graph. So hopefully we should have been able to do that by now. So we should have ended up with something like this. My graph looks a little bit different because I only have 20s, and so mine's a little bit more spread out than probably yours is. Yeah, yours is a little backwards, so yours is a little bit different. So are we okay with this scatter plot for our warm-up? Were we able to get that?
Yep.
Remember our steps? What type of trend or correlation do we have for this scatter plot?
Positive.
Positive. So it's a little bit, it's a kind of a short slope. It's kind of flat, but eventually as your x's get larger, or as you study more, these students did better on their calculus test. We got better results towards the farther end. So it does have a positive correlation. It does have a positive slope. Good. Good. So today we're going to talk about lines of best fit. And we're going to talk about when we can use a line of best fit, how we can find it, and how we can utilize it. And so we're actually going to do it on, I don't think we have, no. So we have this data right here. So you have the body length of a panda after the age, and I think this age is in months, so I didn't put that on there. So you have the age of the panda in months, and then the body length of the panda in centimeters, I think it's what that was, not centimeters. Inches, I don't know, it's something. Feet. So that's your panda, there's your body length. Graph this data with the scatter plot. Figure out what your correlation is, just like what that last problem is. Your age is going to be your x. Your body length is going to be your y. So figure out what's the highest point, how far do you need to go to, what should be some numbers you can use. Do I want to go by 5? Do I want to go by 2s? Figure out what you want to go by and graph that data, and then we'll talk about the line of best fit when you get that. Alright, so we should have had enough time to be able to graph this data. So we have something that looks roughly like this. I want to apply 3s on this one. Boys, let's put your ruler down, please. Jody, that means you. Put your ruler down. Let's focus. So, on this data, yours might look a little bit different just because your scale might be different. If you want it by 2s, you want it by 5s, you want it by 10s, whatever. It might be a little bit different, but we should all have a general idea. What did you find for the correlation of this data? Positive. And so, once again, positive means if one variable increases, the other variable increases. So as the age of the panda increases, the body length of the panda increases as well. Good. Can we estimate how long the panda was at 7 months old?
Yes.
About 24, somewhere in there, maybe. What about for 3 years old? Would you be able to estimate that?
Probably like 13.
So these are months though. 3 years old is going to be way over here by the trash can. So we can kind of estimate 7 off of the graph, but once we get off that graph, our scatter plot, we can't really estimate anything past that. Luckily, in math, we can use a thing called a line of best fit. So your line of best fit can be used to help you estimate or predict future events based off the data that you have. Let's sit down, please. So let's listen up. So for your line of best fit, how we create this line is you're going to use your straight edge, you're going to use your ruler, and you are going to try to make the best line you can that seems to pass through these points. So obviously some of the points will be above your line, some of the points will be below your line. You just want to try to estimate the best line you can that will pass through your points. So some of the points might be just above your line, some of the points just might be a little bit below your line. but try to do your best and get that line of best fit. It's called a line of best fit, it's not like a perfect line because it's not going to fit everything, it's just going to do the best you can. And so once again, based off of how your graph looks and based off of how you draw your line might look just a little bit off from what your neighbor does, and that's okay. Lines of best fit aren't supposed to be perfect, so you're not going to get exactly the same thing. But we should have something close. Are we okay with this? Were we able to draw our lines? Okay. Have we done lines, or have you drawn lines of best fit in the past? Okay. Good. Good. So with this line of best fit, this makes it helpful and gives us an even better idea of where that 7 months should be. So I see it might even be like 24 and a half or 25. It's right around there. 24 was really close, but this gives us an even better idea of where that point should be for that month. But how can we use this line of best fit to tell us with 3 months? Because once again, this is only on our, or 3 years, because once again, this is only on our graph. So how can we use it for 3 years?
To make the graph bigger.
You could make the graph bigger, but making the graph bigger would go on and on and on and on. That would be a long time, right? Do you think we can find the equation in this line? And do you think we can use that to help us? So in order to find the equation of a line, once again, for a line, it's y equals mx plus b. What does that m stand for? Slope. What does that b stand for? Okay. So if I were to extend my line a little bit farther, I could probably figure out where my y-intercept is or get a good idea of where my y-intercept is. But I don't really know the slope of this quite yet. But in the past, given 2 points, were we able to find the equation of a line that passes those 2 points? If I gave you an x and a y coordinate and I gave you another x and a y coordinate, you were able to find the slope of that line and you were able to find the y-intercept of that line? So we can use that same method to find the slope or the equation of this line of best fit. All we need to do is we just need to pick 2 points on this line that seems to be passing through our line, and then we can use those to find the equation of the line that passes through that. So the 2 points I picked were 212 and 416.5. So these were 2 points on our data that our line of best fit was pretty close to. So using those skills that we learned in the past, we want to be able to find the equation of the line that passes through this. So a quick refresher on how we go about that. First thing we want to look for, it's been doing that all day, it's weird. First thing we want to we want to find the slope of our line. So with slope, we do y2 minus y1 over x2 minus x1. So I have 16.5 minus my y1, which is 12, divided by my x2 minus my x1, which is 2. So 16.5 minus 12, that gives me 4.5. 4 minus 2 gives me 2. And then I can kind of simplify this if I do 4.5 divided by 2. That gives me 2.25. That is my slope of my line. What? 16.5 minus 4. With your lines of best fit and with these equations, they're often going to be, you're often going to get some uglier numbers. They're not all going to be integers. They're not all going to be nice cold numbers. We're going to get some ugly numbers. And the reason is because we're working with real data. Everything in real life, you're not exactly 4 inches tall. You're probably not. That doesn't make sense. You're not exactly 5 inches or 5 feet and 6 inches tall. You're gonna be 5 feet 6 and like 3/8 of an inch. You're not gonna be perfect. So we're not gonna deal with perfect numbers. We're gonna get a couple decimals, and that's okay. We just need to work with them. Typically, when you get decimals, try to keep it to the hundredth place. So try to keep 2 decimal places if you need to round. If not, just try to keep it in. What was that? So one question was how long is the panda at 7 months? One question was how long is the panda after 3 years? So we'll have to make some conversions for these ones. So we have the slope of our line though, but that's only one thing. We also needed the y-intercept. We could look back on the graph and see what the y-intercept was from the graph, But if we want to find a more accurate number based off rather than just sort of guesstimating from the graph, we can find the y-intercept using that method we learned 2 weeks ago. So we know our equation is y equals m, which is 2.25, x plus b. In order to find that y-intercept, I can't have that x or my y in my equation. So I need to plug in a point for x and y. What should I do? So I have two options. I have 212 and 416. I can plug either of these into my x and y. I'm going to use 212 just because that's got some smaller numbers. So 12 is my y-axis. And then with a 2 was at the other point. 2 is my x. And then we need to solve for b. Okay, boys, put down the helicopters, please. Thank you. So 2.25 times 2, that should give us 4.5 plus b equals 12 minus 4.5, and 12 minus 4.5 should give us 7.5. So we take our b, plug it back into our equation, and we should have our full line of best fit. So y equals 2.25 plus, or 2.25x plus 7.5. What? Mary?
It's Spanish.
Okay.
The word for brother.
All right. So we have the equation of our line of best fit. Now that you have the equation of this line, let's listen up. Now that we have the equation of this line, we can use it to solve for other information. If we want to predict future events, we can predict it based off of this line which we got from our data. Yes, we can predict the future. For example, if we wanted to predict how large the panda will be after 3 years, we can take that information, plug it into our equation, and find the length. The thing is, this equation, this is for months. How many months is 3 years?
36.
36. So it'll be 3 times 12, so that's 12 months a year. So we're going to take the number 36, and we are going to plug this into our equation. I'm going to put it on another thing. So we have y equals 2.25x plus 7.5. So we are going to take our 36 months, and we're going to plug that in for our x, our months, to see what the size of the panda is, the y. So y equals 2.25x times 36 plus 7.5. 2.25x times 36. Or I have to put that in a calculator. Yes.
There's no X.
So we substituted 36 in for our x, because this is our x represents the age of the panda. We're looking for the age of the panda after 36 months, so we're going to substitute that in. So if we were to plug this into a calculator, you can take 2.25 times 36. That gives you 81 plus 7.5, which gives us 88.5. I think we said it was inches at the start. So with these lines of best fit, we can predict the future. Using your data and using the relationship you found among that data, you can create a line of best fit, find the equation of that line, and you can use it to predict future events and future answers.
I predict tomorrow
Okay. So the main thing we want to focus on today, we want to focus on just being able to create that line and find the equation of that line. Don't worry necessarily about predicting. We'll practice that more tomorrow. But the main thing we want to focus on today is being able to create that line. So I have some data for you. Your goal is to plot this data, draw your line of best fit, and then using 2 points that your line passes through, see if you can find the equation of that line. For your data on this one, it doesn't start at 0. It doesn't start at a smaller number. So if you want your graph to start at, for example, 30, no, your smallest number is 25. if you wanted your graph to start at 20 and go up from there, you can do that, rather than starting at like 0 and going up. Same thing for your y. If you want to start at a lower number for your y or a higher number for your y, rather than starting at 0, it makes it easier to plot your points. So find your scale, plot your points, see if you can create your line, and then see if you can pick 2 points on that line to create your equation. Boys, let's listen up. So you may still be working on your data. That's okay. We're going to work through this example together just so we have another example to look at, just in case you haven't quite been able to finish. So you should have been able to plot your data. We then graph our line of best fit. That looks okay, I guess. I'll say that works. So you get your line of best fit. Notice we have a negative correlation. So our slope of our line needs to be negative. We know that should happen. We have a negative correlation. So in order to find the equation of this, I need to pick 2 points. So looks like this point, oh, that's not what I want. This point and this point look nice. So that gives me, that's 2576, and my second point was 4332. So these are the 2 points I'm going to use for my slope in order to find my equation. So 2576 and 4332. Yeah. So once again, in order to find slope, we're going to take our y2 minus y1 over x2 minus x1. And once again, we're probably going to get some ugly numbers, but that's okay. So 32 minus 76, that leaves me with negative 44. 43 minus 25, that gives me 18, yes, thank you. Negative 44 divided by 18, you can leave this as a fraction, or you can put it into the calculator to see what it turns out to be as a decimal. So negative 44 divided by 18 gives me with negative 0.24 repeating. So I'm going to round it to my nearest hundredth. So my next 4 is going to round down, so I have negative 0.244. So this is my slope of my line. Once again, depending on the picture, or depending on the points you chose from your line above, your slope might be different from my slope. Not everyone's going to get the same answer. That's okay. So we want to use this to find the y-intercept. So right now, all we have is y equals negative 2.44 x plus b. In order to find the y-intercept, I need to plug a point in for my x and my y. So what point should I use? I think I'll use 276 or 2576. It doesn't really matter which one. You could use 4332. It'll give you the same answer. It doesn't matter. I'm going to use 2576. But once again, we plug our x and our y into that equation. Multiply first, so negative 2.44 times 25. Can someone do that for me really quick?
Negative 61. I just came up with that.
So negative 61.
Negative 61.
We'll get some nicer numbers than I expected. In order to solve for b, I need to get this negative 61 over to my other side, so I'm going to add 61. 76 plus 61 should give me 137 equals b. I need to rewrite my equation so I get my full line. Y equals negative 2.44x plus 137. I could then use this to find any temperature at any latitude that we have. So based on our information, we were looking what's the latitude in degrees, and that gave you the temperature in Fahrenheit. So if I want to find what was the latitude at 47, if that wasn't part of our data, I could plug 47 into our equation, and that would give me the temperature at that latitude. Yes, what's your So it's okay if your number is different from what your partner or person sitting next to you got, or from what I got up here. That's okay. Because when we draw the line the best fit, everyone is using a different, everyone's estimating a different way. These are estimations. So not every number is going to be the same. The 2 points that you choose are probably going to be 2 different points than what I chose. And so because you chose 2 different points, your line is going to be close, but it'll be different because those are 2 different data points. And so we use these as estimations. None of this is going to be perfect. None of this is going to be exact. They're all estimations. And so don't freak out if the person sitting next to you gets something different. You should be close to each other. You should be in the rough, like you should have the same idea of what the slope is. You should have a similar y-intercept. They won't be exactly the same, but they should be close to roughly the same. So if you got a negative number between 1 to 3, then you probably have the right idea. So we're going to practice specifically tomorrow using these lines of best fit to be able to make predictions. So we'll practice being able to graph them tomorrow. We'll practice being able to make predictions with them. Same thing with Thursday. And then this will be what our quiz will be over on Friday. I'll give you some data. I'll ask you to plot it. I'll ask you to find the line of best fit. I'll ask you to use it as a prediction. And that's your quiz. It's all like one big problem together. Are we okay with this today so far?
Yeah.
Any questions before we end it? All right. Good job. Thank you. Yeah, bring the rulers back up, please.